So I'm going to just talk you through these methods. I really hope it's recording my voice. If it's not, I'm going to end up recording this twice. That's fine, whatever. So I'm going to talk you through two methods. I prefer the first one personally because I feel like you're less likely to make mistakes. But you might prefer the second one. So I'll just talk you through both for the first problem, and then I'll get you to have a look at it and let me know which one you kind of follow along with better. And then we can kind of stick to that for the time being. So here's the first problem. I really hope I've written the signs out correctly from the picture. The picture was a bit hazy, but I think it is because I've already worked it out and I got exact values, so it probably is correct. So here you've got the first problem, 9x plus 3y minus 4z equals 37, 4x plus 3y plus 7z equals 16, and then x minus 5y plus 8z equals minus 31. So the first step is to label the equations 1, 2, and 3, and this just helps you to eliminate certain problems. Okay, so I can see that. Now, the first thing I want you to notice is you can eliminate one of your variables quite quickly because you've got 3y in both of these first two equations. And then if you can get rid of one of the variables, then you can make it look more like a normal simultaneous equation where you've only got two variables. So always look for that. So I'm going to take equation number 1 and I'm going to subtract equation number 2 in order to get rid of the 3y's and just be left with x's and z's. So we have equation number 1. Actually, I'm just going to copy and paste it. Hold on. I'm just going to copy and paste that and get rid of my lovely little circle. Right. So if I do equation number 1, subtract equation number 2, I'm just going to put brackets around and then put a minus sign to make sure that I'm getting my signs correct, because that can be one of the biggest mistakes people make. So we just start by subtracting like terms. So we have 9x minus 4x gives me 5x. 3y minus 3y is going to give me no y. So that's now eliminated, which is great. That's what we wanted. And then we've got minus 4z minus 7z is going to give me minus 11z is equal to 37 minus 16 is going to give me 21. So now the y is gone. Now, the only trouble is with my other equation, I still have a y, and it's not as easy to get rid of because, as you can see, it doesn't match. But that's fine. We can just kind of manipulate one of the other equations in order for it to match. So let's just get rid of this circle. And then I'm going to pair it up with equation number 2 again, because it's just more positive, so less likely to make mistakes. It really doesn't matter which one you choose, though. You should still get the right answer, but I would advise you pick ones with the smaller coefficients or positives. So we're going to take this and we have to basically change these so that the y's match. And I do have to eliminate the y's. I can't eliminate the x's or the z's because otherwise I'm not going to be able to pair it with this equation up here and treat it like a normal equation where I have two variables. So how do I combine these? Well, I have to find the lowest common multiple, which is going to be 15. So basically, I'm just going to times the top equation all through by 5 in order to make the 3y 15 and the bottom one by 3. Okay, so I'm just going to times that through now. So 4x times the 5 is going to give me 20x. 3y times 5 is going to give me plus 15y. 7z times 5 is going to give me plus 35z, and then 16 times 5, so 16 times 10 would be 160, so it's going to be 80. Okay, now we have to times the bottom one through by 3, so x times 3 is going to be 3x, minus 5 times 3 is going to be minus 15, so that's minus 15y, and then 8z times 3 is going to be 24, so plus 24z is equal to minus 31 times 3 is going to be minus 91. And that's all looking correct, I believe. Oh, no, wait, hold on. It's going to be minus 93, isn't it? See, it's even little things like that can end up giving you the wrong answer. Okay, that's looking better now. Okay, now I need to get rid of the y's. So you have a positive up here and a negative down here. So we have to get it to minus. So basically that means I'm going to have to add everything here, because a positive and a negative is going to make a negative, and I want to subtract at the end of the day. This again can be tricky, but if you get simultaneous equations with two variables, then this shouldn't be so hard. But you'll eventually get the hang of it, even if you are making mistakes. Just try both and make sure you are in fact eliminating, and check the value that you're eliminating is actually disappearing. Don't just assume it's going to disappear unless you're sure you know what you're doing is correct. Okay, so we're going to add the top equation to the bottom equation. So we have 20x plus 20 plus 3x is going to be 23x. 15y plus minus 15y is going to be minus 15y, so that's going to be nothing, so that's great, that's gone now. Then 35 plus 24 is going to be plus 59z, and then we have 80 minus 93, basically is going to be minus 13. Okay. Now we have two equations which have only x and z, so I now have to put them next to each other and combine them again. So again, they're not very easy to combine, so it's up to you which letter you want to eliminate. I would pick the x because these numbers are super funky, and at least here I've got a 5, so one of the numbers is still a little bit smaller. So I'm going to get rid of the x's by basically multiplying both equations through. So top equation I'm going to have to times through by 5, and bottom equation I'm going to have to times through by 23. So 23 times 5 gives me 115x. 59 times 5 gives me plus 295z. And then minus 13 times 5 gives me minus 65. Now the bottom one, so we're going to do 5x times 23 gives me 115x, which is obviously what I'm going to use to get rid of it. 11z times 23 is going to give me minus 253. The minus is coming from the minus 11, obviously. And then we have 21 times 23, which gives me 483. Okay. Now I can just get rid of the x's by subtracting. So I'm going to subtract this whole thing through. So we have 115x minus 115x, that's going to cancel. Then 295 minus 253, so we should end up with 548z is equal to minus 65 minus 483 is going to give me minus 548. And just take this bit slow, make sure you're doing it on the calculator, don't guess it, and you should be okay. And you can see now z's just going to be equal to minus 1. So after all of that and all of those big numbers, we end up with z equals minus 1. So yeah. Okay. Now the easiest way to get y and x is to use your simplest equation. So I'm going to take, for example, this one. It looks like one of my simplest ones, in order to work out what x is going to be. I just need to duplicate that and bring it down, and I actually need it to come down, so this is being annoying now. Copy. Okay, there we go. And I'm just going to sub in minus 1. So we have 5x minus 11 times minus 1 equals 21. Minus 11 times minus 1 is going to be plus 11. So we have 5x plus 11 equals 21. We're going to subtract 11 on both sides. So we're going to end up with 5x is equal to 10. And therefore x is equal to 2. And then again, we want to pick a nice simple one to substitute into. You might think the bottom one is the easiest one to substitute into, but again, I think actually the second one is the easiest one to substitute into, because it's positive numbers and not very big numbers. So we're just going to take 4 times 2, so this I'm getting from 4x plus 3y plus 7z is equal to 16, and I'm just going to substitute minus 1 and 2 into them. So 4 times 2 plus 3y plus 7 times minus 1 is equal to 16. So that's 8 plus 3y minus 7 is equal to 16. 8 minus 7 is just going to be 1, so we have 3y plus 1 is equal to 16. So 3y is equal to 15, so y is equal to 5, right? Yes. So there's my answers. So we have x is equal to 2, y is equal to 5, and z is equal to minus 1. I'm going to stop the video there, and then I'll do the other method another video because it's not going to get too long.